This is AQA Statistics, Continuous Random Variables 4. This video is about the rectangular distribution. The probability density function for the rectangular distribution takes a constant positive value k between minimum and maximum values a and b. F of x is 0 outside this range from a to b. So here we can see the PDF, and it takes this constant value k where x lies between a and b, and then it is 0 elsewhere. It's important to notice that f of x does not depend on x. The shape of the distribution is a rectangle. The area under any PDF must be 1. Here, the area we're speaking about is this. So what that means then is that k times by b minus a must be equal to 1. We can therefore infer that k, the constant, is going to be 1 over b minus a. The PDF can therefore be written in this alternative form, where instead of k we show this fraction here to represent the probability density. Please pause the video to read the example and work out the answers for a, b and k. Now a, the minimum value for the arrival delay, is -2 minutes. So that's the train arriving 2 minutes early. The maximum delay then is 8 minutes, train arriving 8 minutes late. And k we can work out as 1 over b minus a. So that's going to be 1 divided by 8 minus -2. So that's going to become 1/10. Please pause the video to read the example and think about why a rectangular distribution would be suitable. Now this example is about rounding errors, and the scales, the bathroom scales, weigh to the nearest tenth of a kilo. So it is the 0.9 of a kilo here in this example that is significant. So that means to say that the error, the rounding error in the measurement, can be anything less than plus 0.05, anything greater than minus 0.05. It's reasonable to assume a constant probability density. There's no reason to assume that the error would lie in a particular place within that interval. So here is our rectangular distribution, and here is k, the constant probability density. Now to work out k, what we need to do is to figure out the value of 1 over b minus a. And we can see that b minus a, from these values down here, is going to be 1 over 0.1, and that's going to be 10. So to specify the distribution then, here is the PDF, and f of x equals 10, within that range between minus 0.05 and plus 0.05, and PDF is 0 elsewhere. Please pause the video and work out what the probability that x is less than 5.2 would be in the case described in the diagram. Well, what we've got here, if we just pop for 5.2 approximately here, then we're looking for the probability that x is less than 5.2. So it's this area here we're trying to find. And we can see that that rectangle then has a height of 1/5 and has a width of 5.2 subtract 2. Let's take a look what we need to do there. So we're going to say the probability that x is less than 5.2, that is going to be 1/5 of 5.2 less 2, and that's going to, we put that into a calculator or work it out in our heads even, it's going to finish up being 0.64. We're going to derive the cumulative distribution function for the rectangular distribution, and we've got the usual diagram here, and instead of putting a particular value here, we're considering a variable value x here that lies between a and b. So we can see that the area then of that rectangle is going to be the height times the width, and the width there is x minus a. So that's the area of that rectangle there, and that is going to represent the cumulative distribution function. It's going to represent the cumulative probability. So just putting that as a single fraction here, here's our CDF within the limits between a and b. When x is less than a, the cumulative probability is 0, and when x is greater than b, the cumulative probability is 1. Please pause the video to read the example and attempt the integration here. We're not using the formula from the previous slide. We're actually going to derive this CDF, as shown here, by integration. So let's take a look then at a value x that lies between 2 and 7. Then the area up to that variable x can be found by integration of the PDF. So here we are then, f of x is going to be the integral from 2 up to x of the PDF, which is 1/5 with respect to x. That's going to give us x over 5 evaluated between at the values x and 2. So put that over here then, that's going to be x over 5, take off 2 over 5, which can be written as shown up here as one fraction, and that's the value between x is 2 and 7. Now the PDF for x less than 2 is 0, so therefore the cumulative probability is going to be 0 here, and all of the probability lies up to the value 7, so that therefore for any value greater than 7, then f of x is going to be 1. That completes this video. The next video is on deriving the formulae for mean and variance of the rectangular distribution.